Hello friends, welcome to Brilliant Mind Scholars. On our lectures today, we're going to be studying complex numbers, right? And in complex numbers now, we're going to be looking at how we can find higher powers or higher exponents of I. Now, in the previous video, we showed us how we can find some of the powers of I, such as I raised to power 1 now, which will give us I. And we said that I raised to power 2 would give us minus 1, and we said that I raised to power 3 now would give us minus I, and we also said that I raised to power 4 now would give us 1. We were able to study how all these are possible right in the previous video. Please do well to check out our playlist and find the previous videos so as to understand some of these concepts better. We were able to work with these concepts right down to even I raised to power 10. So we said that I raised to power 5 now, I raised to power 5 would give us I. We said that I raised to power 6 now would give us minus 1. And yes, we were able to also establish that I raised to power 7 would give us minus I. And we also established that I raised to power 8 now would give us 1. We did that all the way down to 10, and we looked at higher numbers, right? I raised to power 9 now gives us I. How true. And I raised to power 10 now we established I raised to power 10 would give us minus 1. How true. Very true, very true. Recall that we said that I raised to power 4 serves as a landmark, right? I raised to power 4 serves as a landmark. So when we get to I raised to power 4, every other variable such as I raised to power 5, 6, 7, 8, 9, and 10 begins to repeat themselves, right? Such that I raised to power 5 will give us the same value as I raised to power 1. So we notice down that I raised to power 5 here gives us I, and I raised to power 1 gives us I. The trend continues like that, right? So I raised to power 6 now would give us minus 1. As you can see, this gives us minus 1. I raised to power 7 now would give us minus I. As you can see, that gives us minus I. And I raised to power 8 now would also give us 1. I raised to power 8 also give us 1. So that's the trend. So you can keep on counting like that. When you get to I raised to power 4 again, you start from the top to I raised to power 9 now would give us the same value as I raised to power 1, which is I. How true. That's what we have here. Here's another trick that can help us find higher powers or higher exponent of I. Suppose we are asked to find I raised to power 12. I raised to power 12. The first step we'll take is divide 12 by 4. 12 divided by 4. And this gives us 3. It's a perfect division. So since 12 now is perfectly divisible by 4, so it would mean that I raised to power 12 would be the same value as I raised to power 4. And we said that I raised to power 4 gives us 1. This is what we're going to have. Let's write this one properly. This is what we're going to have in this case. Now, suppose now we are asked to check the answer using our method now of counting, right? So using our method of counting now, using our normal method of counting now, we have that I raised to power 9 gives us I, right? And I raised to power 10 now, I raised to power 10 would give us minus 1. I raised to power 11 would give us minus I, and I raised to power 12 now would give us 1, which is the same as what we got in this case, right? So whenever your power is perfectly divisible by 4, it would give you the same value as I raised to power 4. The same rule apply, right? So if we are told to find something to the extent of I raised to power 32, the same thing applies. So we try 32 divided by 4, 32 divided by 4, and this would give us 8. So 32 is perfectly divisible by 4. This would mean that I raised to power 32 would be the same value as I raised to power 4, and this would give us 1. How true. Whatever number it is, right, as long as it's perfectly divisible by 4, it would give us 1, which is the same value as I raised to power 4. Now, the question on most of your minds would be, suppose we are given a power now that is not perfectly divisible by 4, right? Very true. Let's take this off the screen and let me show you how we're going to work with that. Now, suppose we are given a power that is not perfectly divisible by 4 now. How do we work with that? How do we handle that piece, right? Suppose we are asked to evaluate I raised to power 11. I raised to power 11. So, the same rules apply, right? We divide by 4. 11 divided by 4. Now, we have to work with our remainder, right? So here now, this would give us 2, remainder 3. So 4 into 11 now would be 2 times, right? 4 will go into 11 twice, and you will have a remainder now of 3, right? So 3 remains. Now, it turns out now that I raised to power 11 then would be the same value as I raised to power this remainder you have here. So that would be I raised to power 3. So I raised to power 11 becomes the same value as I raised to power 3. And we know that I raised to power 3 gives us minus I. This is what we have in this case. So I raised to power 11 here now gave us minus I. How true, how true. So the same rule apply, right? Suppose we are also asked to find I raised to power 25. I raised to power 25. 25. So we check now. 25 divided by 4. 25 divided by 4. And from our multiplication timetable, 24 goes into 25 6 times, right? 6 times, remaining 1. Remaining 1. So what we have now would be that I raised to power 25 would be the same value as I raised to power the remaining one of what we had from our division, right? So I raised to power 25 is the same as I raised to power 1. And this now, let's write this properly, I raised to power 1. And this now would give us I. How true, very true. So that's how we can evaluate higher exponents involving I. So here are some questions that I would love you to play with, right? So you can solve these questions and leave your answers in the comment section. Thank you guys. Thank you so much for watching. See you in the next video.